This is the week 4 for chemistry for term 3 and explaining chapter 8. So symbol H refers to the heat content of substance, how much heat there inside any substance. Is it a beaker, is it a tube, is it a flask? So you choose that which of the following symbols refer to the heat content of substance, that's H. And then we have to speak about the chemical reactions. They are endothermic and exothermic chemical reactions and what's the difference between them. And just try to focus on your flask or your system. Is it absorbing heat? So there is heat coming inside, or there is heat being released. If the heat is released from your flask or your system that you are focusing on to outside, then it's called exit. And if the heat is coming in, if it's absorbed, then it's to your system, then it's going to endo, it goes inside. So endothermic reactions. So any reaction that there is a temperature rising, you'll see that there is 10 has changed into 100, this is exothermic, and if it is 100 into 30, this means the temperature has dropped, so it's called an endothermic reaction. So what are examples of the reactions which are endo and exo? He's asking, is it melting ice cube, heating carbon with water vapor? How I'm gonna know that? Let's have a look a little bit about exothermic reactions, understand more things. The chemical reactions which are exo are examples, are anything which there is freezing or condensation or burning. These are the examples of the exothermic reactions and also the neutralization reactions. You have to memorize this. So anything in which I'm breaking some bonds, no, I'm making some bonds. I'm changing from a gas into a liquid. So to change from gas to liquid, you make bonds between the gas particles, or to change from the liquid to solid, you make bonds between the liquid particles, more bonds to form the solid. In this case, or any changes from gas to liquid or liquid to solid, this one is called freezing, and this one is called condensation. Freezing and condensation, this will be considered as exothermic reactions. Any reaction like that will be exo. It will release the heat. Also, any neutralization reaction, like example between HCl and NaOH, this is going to be a neutralization reaction in which a salt and water is formed, and this is going to be exothermic reaction. You will see a temperature rise. You will see a temperature rise in this reaction. Anything that's combustion, when you see heat is produced, not given. Heat is produced in the reaction. Combustion reaction, you are burning anything. You are burning methanol, you are burning a fuel, you are burning methane. Anything that's burning will produce an exothermic reaction. Temperature has risen. While anything that's opposite to that is always an endothermic reaction. So if you are moving from solid to liquid, you are breaking the bonds between the solid particles to form liquid, or breaking the bonds between the liquid particles to form gas. This is called an endothermic reaction. Or melting is endothermic. Evaporation, sublimation directly from the solid to gas, this is called an endothermic reaction. Some reaction like C plus H2O give us H2. This reaction is mentioned as a question and is called heating. You see that there is heating. Take care, this heat is produced, so it is exothermic, while heat is added. I added heat to the reaction. I make evaporation by adding heat. I make sublimation or melting by adding heat. This one is endothermic reaction. So you see the examples that I can get from here is melting an ice cube. We said melting is an endothermic, and heating carbon. So heating, I put heat, so this is an endothermic reaction. While cooling, no, I did not put heat. Heat is removed, so it's exothermic reaction, and reacting sodium hydroxide with HCl, we said this is a neutralization reaction. Any reaction between an acid and a base is called neutralization reaction, in which the temperature increases and is considered as exothermic reaction. So you have to memorize this very well. I'll just put it here so you can screenshot it and put it in the exam, the endothermic and exothermic reactions. Okay, this is an old question. Question number 4, change in heat content is symbolized by delta H. So anything action in which there is a change in heat content. So the flask, in this flask, you are focusing how much heat content is there, is H1 at the beginning. At the beginning, when there are reactants before the building of the reaction, and then what happens after the products are formed. If H1 and H2 has increased, in this case, I will call it an heat loss or heat gained. I have gained here. I have 300 heat and become 500 heat, let's say kilojoules unit of heat from 300 to 500. It's like your wallet. Your wallet has 300 and now it has 500. Why? Because you have added. So it's an endothermic process. The change is positive change. The change is positive change. So it's increased. So it's called delta H has increased. The change is by increase, by plus 200. While if you have removed money from your wallet, it has 300 and become 100. This is because there is a decrease. So the change is by decreasing. You have decreased. So this is an endothermic reaction. So this is an endothermic or exothermic reaction. It's an exothermic reaction. This one is exothermic reaction, while this one is endothermic reaction. You have added here, so it is endo. While you have lost here, so it is exo. This is endo. So this is endo because you have gained heat. So if the amount of heat in the the product is more than the amount of heat in the reactants is because you have added, it's because you are endothermic. While if the amount of heat in the product is less, it's less than what's in the reactants because you have lost, you have minus 200, have lost it to the surroundings. That's why it's called exothermic reaction. It's called delta H or heat change or enthalpy change. Don't worry about the word enthalpy, you can always change it into heat change. Question number 4 now is answered. The change in heat content is symbolized by delta H. What about the Hess law? The Hess law is telling you if you go from your home from point A to B, then is going from home to work. It's the same like going from A to C and then C to B. It doesn't matter where did you go, what is your path. It doesn't, it's independent of the path. It's not important. The path is not important. Path 1 or path 2. So you go from here to here, or you go from here to here, it is the same thing. This is what His law is telling you. It's independent of your path, but it depends on the reactants and products. Where did you start and where did you end? So it doesn't, independent of the path followed, it depends only on the initial reactants. The reactants, it's important that you started at the same point and ended at the end the same point. So it depends on the initial reactants and the products and their state. So if you started with a gas here, then the other reactions that you use must be a gas here. If you ended with a gas, then the reaction also has to be a gas. So his law states that the heat evolved or heat absorbed in a chemical reaction does not depend on the path. It depends only on the initial reactants and the final products and on their physical states. Let's see how can we calculate this delta H. The change in the delta H can be calculated by 3 methods in our service. The first one will be called calorimetry. The second one will be called using bond energy, like in this example. And the third one will be called Hess's law. So 3 methods to calculate the delta H: calorimetry, bond energy, and Hess law. The first question, which is question 6, is asking you how to measure the delta H by the bond energy. And it has a rule. The rule tells you that if you look at the chemical reaction and you see how much heat is being broken or being made. So in this chemical reaction, there are 2 steps usually. The first step is that when you break bonds, like if you want to make a reaction between H2 and Cl2 to form HCl, you have first to break bonds. So if you have H2, this is H, and this is H, and this is Cl2, so this is Cl and Cl. If you want to make HCl, the first thing is that you have to separate these 2 from each other. So H is separated from H, and Cl is separated from Cl. In order to do this, you have to break bonds. So you have to break bonds. And since you want to break bonds, you have to put some energy here. So put energy here. So this is the energy that you will use to break bonds. And then this is the sum of this energy. And this sum energy is called sigma. So sigma of the energy placed to break bonds. So energy in the bonds broken, and then subtract this from the energy that you will use to make the bond. So after that, take this H and join it with 1 Cl, you make a bond between them, and take this H and make a bond with the Cl. So there is bonds which are made. The total of the energy in the bonds which are made are subtracted from the total of the energy in the bonds broken, and you will get your delta H. So add all the energy here and add all of the energy here, which will be given to you. So he'll tell you how much heat you needed in order to break the bonds and how much heat you needed to make the bonds. In order to break the bond between this H and H, you will need this energy, and you need to break the bonds between this Cl and Cl, you need this energy. And in order to make a bond between an H and Cl 2 times, he will also give you the energy for that. All you have to do is subtract these 2 values from each other, but watch for the values. That's why I put them in color so that you will be thoughtful about them. And then we'll make it a little bit bigger so you can see what's happening here. So the delta H of the bonds broken, there is a bond between the C and C. This one you can see it in the pink color, and there is a bond between the CH and the CH. This is 4 times, actually 4 times. So we can say that 413, which is the C and H, is repeated 4 times, and 602 is the bond between the C double bond, 602, C double bond, 602. Don't confuse this with the C. This is C single bond, 346, a different value. We'll use it later in the products. And there is one green, which is between the Cl and Cl 240. Don't forget, this is still in the reactant sides. So in the bonds broken, you will add everything which is in the reactant sides and make sure that you are very careful about the addition and multiplication in the calculator. So make 430 multiplied by 4 plus 602 plus 240. Add this all, you will get a result of 2,494. And then you look at the product side, the energy, the sum of the energy in the which is made due to the formation of bonds between the C and C is 346. And between the CH and the CH, this is the same one here, repeated again 4 times, which is still 413 between the C and H, but C and Cl is different. This one, C and Cl, is 327, and it's only found 2 times. So this is 2 times. So 327 multiplied 2 times. Add this all, you will get 2652. So subtract this one from one, you will get minus 158 in kilojoule units. And be careful about this sign. This sign is very important. If you forget this sign, you will lose the mark. You will get a different value plus 158, which is a totally, and you will lose the mark. Okay, so this is a very good way to answer the question number 7, which is a little bit difficult question. In the questions of Hess's law, all you have to do is look at the equations that has given. So look at the given equation. Please follow with me carefully. This is the given equations and the equations which is required equation. You need to manipulate and change your equation from the given equations to the required equation. So how do you manipulate them? You look at two things. The direction, is it the same direction or opposite direction? If it is the same direction, you will keep the value that he has given for you as it is. So if it is negative 427, you will keep it the same. If you reverse the equation, so if the equation that you have, number one, is different in opposite direction to this one, so for example, 3O2, I can see O2 here on the right side. But in the product, I can see it on the opposite side. So this means that you have reversed the equation. So you have to make the opposite value. Instead of negative 427, you will make it positive 427 like that. The second thing that you have to look at is the number of moles. Is the number of moles the same or different? So if you have 3O2 here, but you have half O2 here, means that you have also to manipulate the number. You have to play with the number so that the number is not the same. Okay, this question actually is one of the most difficult questions in the Hess's law. So I'll try to put every reactant or product in the different color so you can try to understand what's happening here. You can see that the oxygen here is two forms, the O2 and O3. The O3 is available as it is, but the number of moles has changed from 2 to 3. This means that I have changed the different number of moles. This is 2 and this is 3. And here the number of moles of oxygen here is 2. Sorry, we don't do this. We do one equation by the equation. So compare one of the given equation to the required equation and compare the other given equation into the second required equation. So see, I have two given equations. I have equation number 1 and I have equation number 2, and I have value for number 1 and I have value for number 2. The value for number 1 is minus 427 and value of the second one is minus 122. So let's see what we will do. Let's look at the second equation, which is a little bit easier. I have NO here in the yellow color and it's the bottom here in the yellow color. So see, is the direction the same? Yes, both of them are in the reactant side. So don't do anything with the number. It's keep it as it is, negative 427. Don't change the negative sign. So it's still negative. And on the other side, look at the other one. Now, Mr. This is NO here. So this is NO here is negative 427. You are looking at the second equation is negative 122. So don't do anything with the sign. Keep it negative 122. What about the number of moles? The number of moles here is 1 and here is 1. You can see 1 mole here and 1 mole here. I can see oxygen is a little bit different, but I will tell, and NO2 and NO2. So let's see what we'll do at the oxygen. We'll keep the oxygen at the end. So it's negative 122 because the number of moles is the same and the direction is the same. So keep it as it is. Now add this to the other equation. The other equation is 2O3. I don't see O3 here in the blue at all. I don't see O3. And I have seen O2 has been manipulated, so it becomes only half. So I need to do something with this equation. The first thing is that I'm sure that the value will be reversed. Instead of negative 427, it will be plus 427. Why is that? Because oxygen here is on the right side, but product side, but here it's on the reactant side. So I know it is have been reversed. But what did I do to this equation so that it will be like equation number 3? The first thing that I'm sure of is that I have to do something so that the oxygen will be cancelled out. So O3 will be cancelled out. What you will do so that the O3 will be cancelled out? You will have to put some O3 here. The first equation has O3, and you need to put O3 on the other side also so that it cancels it out. So if this one you have said it is reversed, it's reversed because the O2 is on the left and on the right. So the O3 will be reversed also. So it will be here. So it means that it will be O3 here. So the second equation, you have O3 here. This is NO plus O3 here. And the first equation has O3 here, but the O3 here is 1 mole. So you have to divide this 1 by 2. So divide this 1 by 2. So when you divide it by 2, it will be O3. And when you put the other O3 here, these two will cancel out, so they will not show in the final equation. They will not show in the final equation. So all you have to do is divide the first one by 2. And when you divided the first one by 2, something like it also happened. This one 3O2, so change it, dividing 3 by 2, it give me 1.5 O2. So it become 1.5 O2, which is the same number of O2. Mister, when you divide it by this one, 3 over 2, it become 1.5 O2. So 1.5 O2, and you have O2 here in the second equation. So 1.5 O2 and O2, you have canceled this 1 and 2. So we have only one, we will have only half O2. So the equation finished like the last equation. It become NO and only half O2. And this one, I know it's a little bit difficult to understand this one at the beginning, and NO2 and the O3 has been canceled out. So what I wanted to say is that the first equation, which is 2NO3, this is the first equation, into 3O2 has been reversed, so it becomes 3O2 into 2NO3, and has also been divided by 2. So it becomes 3 over 2O2 and become O3, 1O3. And the second equation, all that you do is that you keep it as it is, so you don't do any changes in it. You don't do any changes in it. So when you added this and this together at the end, what did you have? When you added this and this one, the second equation contained O3. Yeah, it has O3 here at the beginning. So it has O3, NO and O3, give me NO2 and O2, NO2 and O2. So when you reverse it, this equation, the O3 become here and the 3O2 become here. So when the O3 is here, has been reversed, right? We put this already has been reversed. We did it as a reversal. We did it as a reversal. So when you put this equation, O3 here, and the 3O2, 3 over 2 become here. So the 3, let's make it a little bit smaller so it fits. So it become here. So now what do you have? This one is cancelled out with this one, and the 3O2 cancelled with this one. So it give me only half. So it gave me only half O2. So this is the final equation. So the first equation has been divided by 2 and change it so 427 divided by 2. So what do you get? 427 divided by 2 is 213.5 with a positive value. And the second one remains negative 122. So when we add these two together, what do you get? You get 91.5. And don't forget the positive sign is very important. If you forget the positive sign, you might lose the mark. The next question is a little bit easier one. This is equation number 1 and equation number 2. I can see that equation number 1, the carbon monoxide is here on the right side, but here on the left side. This means that I have to reverse the value. But the number of moles is still the same. There is 1 mole and 1 mole. So don't do anything, multiply or division. This is changed only from minus into plus 110. The second one, the CO2 is on the same side, so you don't reverse the sign, and the number of moles still the same, one here and one here, so it keeps the same. Then add them together. So 3 steps you did. The first one is checking the first equation. It's from 1 to 3. You can see that it's only reversed. It changes the direction, so it changes the number of moles is the same, so it keeps the number of moles. And then when you add these two together, you get minus 283. This is the last step. This equation is a little bit easy equation. He's saying that when you have 1 carbon mole plus half mole of oxygen, and then you change this one into CO, what happened in this case? Let's start, just make it a little bit bigger so I can see it. Here I don't see what happened. This is give me CO, and there is amount of heat released because it is minus 110. Then what do you do? Mr. 110 negative means this is an exothermic reaction. This is the heat will be released with the products. So you said just change it into whole number. So multiply everything by 2 because you want to get rid of this half. So you need to multiply it by 2. So you cancel 2 is 2 and get 1 oxygen only, 1 mole of oxygen only, and keep the physical states as it is. Don't forget. Because you multiplied this one by 2, so you have multiplied everything else by 2. The carbon will become 2, the carbon monoxide will become 2, and this negative will be still negative 220. But Mr., when you the exothermic reaction, take care, when the exothermic reaction, when you write it separate, it will be a negative value, so negative 220. But when you put it inside the equation, you have to remove the sign. So again, when you put it inside the equation, you have to remove the sign. So put it plus 220, but put it in the product side. If it was in the reactant side, so will be endothermic reaction, but we don't put it in the. How did you know, Mr., it is heat absorbed or heat released from negative here. So from the negative here, it's showing. So this means that this is in the product size plus 220. The next question, number 10. I have S plus O2, give me SO2. This is delta H is equal to negative 297 heat released. Write the reverse action of the above reaction without including the energy value. So I'll just put the reaction SO2, I'll put it SO2, and then forms S, and then forms O2. Now, find the delta H. Mister, if you reverse the equation, the value is reversed. So instead of negative delta H 297, it will be positive, which means if you reverse any equation and change it from endothermic into exothermic or exothermic into endothermic. This reaction is the same way nitrogen monoxide reacts with oxygen to form nitrogen dioxide and 112 kilojoules. We are just asking you to put this 112 kilojoules inside the equation. It depends if it's exo or endo. How do you know it's exo or endo? If you said it's released, so it is exo. If you said it is absorbed, so it is endo. He said released, so it is 56. Mr. It's 112 here. Why he did not say 56? Because he said nitrogen monoxide reacts with oxygen to produce nitrogen dioxide gas, releasing 56 per mole of nitrogen monoxide. Look at nitrogen monoxide. Don't confuse NO and NO2. Nitrogen monoxide is NO. He said for every mole of nitrogen monoxide, for every mole of this one, it's released 56. So if the equation is NO, 1 mole only, and O2 and NO2 plus 56 kilojoules released. You said, Mister, it is exothermic, it is negative 56, but when we put it in the equation, we don't put the sign, we put it plus 56. And now we multiplied everything by 2. Why? Because it's said here by 1 mole of NO, but here 2 moles. So put 2 NO plus. That was half at the beginning, that was half at the beginning. Now it is O2 and 2NO2 and 112 kilojoule. Don't forget the physical states. Question number 12 is an old repeated question, and question number 30 also old repeated, and 14, and that's the end of it. Okay, just don't forget to like and subscribe to this, because we'll be adding more videos, and we are also more explanation for chapter 8 and the previous and old chapters. And you can also comment on if you have any problems. We can try to repeat the questions explanation. Thank you so much, Mr. Hisham Mahmoud.